This is question 4 on your test that says that the average math SAT score is 521 with a standard deviation of 112. So notice that is true of, that's not from a sample, that is information provided for us about the entire population. So I've labeled that mean mu and that standard deviation sigma. Now in this case, unlike question 2 on your exam, where we did not know the standard deviation of the population, but rather only the standard deviation of the sample, here we know the standard deviation of the population. And when you know the standard deviation of the population, then you can use the normal curve. You do not need to use the t distribution. So we read on and it says, a particular high school claims that its students have unusually high math scores. So they're basically saying it's above average, which is why in my alternative hypothesis, I've said that mu is greater than 521. So a random sample of 40 students is taken, and the mean SAT score of those 40 students, which would be our X bar, is 558. Is the high school justified in its claim? So what we have to do first is calculate our test statistic, which again will be Z, because it's a normal curve because we know sigma. And Z is found by taking our sample average minus our population average divided by our standard error, which is found by taking sigma over root n. So in our case here, we're going to take our sample average of 558 minus our population average that is claimed of 521 and divide by our standard error, which is found by taking the standard deviation of the population, 112, and dividing it by the square root of our sample size, 40. If we round that to 2 digits after the decimal point, that comes out to be equal to 2.09. What that basically means is they claim that the population average is 521, and our sample average ended up being a little more than 2 standard deviations above that mean. And what we need to do is determine how big is that area in that tail out beyond that z-score of 2.09. So here we need to use our table for the normal distribution. Now we can just remember that if you are dealing with the normal distribution, if you go out 2 standard deviations below the mean and 2 standard deviations above the mean, that should contain the middle 95%. That's based upon the empirical rule, the 68, 95, 99, 7 rule. Well, in our case here, our sample average produces a test statistic which is out beyond 2 standard deviations of the mean. So that's why we can say that the high school is justified in its claim. Our z-score of 2.09 is unusual because it does not lie within the range of usual events, which would be within 2 standard deviations. And so our conclusion is, yeah, maybe this high school's claim is correct. Their students perform better on average than the population as a whole.